Hi, I'm Reilly and this is my Green Team Science Fair project. One day, I was sitting in my room, banished from the Xbox for a week because I had played for 3 hours. And I thought to myself, how could I have played for 3 hours when it only felt like one? And then I had an idea for my science fair project, so I quickly formed an experiment for it. My experiment would answer the question, does time really fly when you're having fun? We got some kids together, aged 6 through 12, and had them play video games for a short amount of time, 6 minutes and 33 seconds to be exact. Of course, they did not know this. They were just told it was a random time, 2 to 10 minutes long. After the time was up, they were asked 2 questions: how much they liked playing video games and how long they thought it was. They were then asked to do a tedious task, write the alphabet backwards. Although the time did not change, they were told it was a new random time, 2 minutes to 10 minutes. My reasoning was that when writing the alphabet backwards, they would believe that the time was longer than it really was. And when they were playing video games, the time seemed to be less than it really was. And this is what we got. This graph shows how much each participant liked the video games, shown by the blue lines. 3 being a lot, 1 being hated it. The red lines show how much the participants were off by when they guessed how long they were playing. Because all the kids said they liked or were okay with video games, the results would be the time flies. But surprisingly, the results show that 3 of the 8 kids guessed longer gaming times. This graph shows how much kids enjoyed writing the alphabet backwards repeatedly. This is shown by the blue lines where 3 is loved it and a 1 is hated it. Like the previous graph, the red lines show how much the participants were off by when they guessed how long they were writing. Even though only 1 kid loved it, 4 kids were okay, and 3 downright hated it, 7 out of 8 still guessed that the time was shorter than the actual time of 6 minutes and 33 seconds. This graph shows each kid's error in time in both video gaming, in blue, and writing the alphabet backwards, in red. Whether they liked or hated the task, it is very hard to predict from this data what a kid will estimate when faced with a fun or tedious task. Although this experiment does not support my hypothesis, I have thought of some other ways to make this a better experiment. 1, I could get more test samples for my experiment. 2, I can get older people for my experiment. Younger kids do not seem to have a good perception of time. And 3, I could get a truly rigorous and boring test.